So let us dive into the topic of the first paper that we are going to present. Adversarial learning has been one of the foremost paradigms of machine learning and AI for the past few years. The area of adversarial learning comprises of a broad set of techniques where an adversary is introduced to help the models learn better representation. So we will be mostly talking about adversarial attacks, which had a profound effect on how we perceive the vulnerability of AI models today. So the image on the right was created after adding a minor perturbation to the image on the left, with the sole aim of fooling an AI model. To human observers, the two images are identical, but researchers at Google showed in 2015 that a popular object recognition algorithm classified the left image as panda and the right image as a gibbon. And oddly enough, it had more confidence in the gibbon image. The algorithm in question was GoogleNet, a convolutional neural network algorithm that won the 2015 ImageNet Large-Scale Visual Object Recognition Challenge, which was one of the leading AI challenges of the time. The image on the right is known as an adversarial example. It has undergone subtle manipulations that go unnoticed to the human eye while making it a totally different sight to the AI model. So adversarial examples exploit the way artificial intelligence algorithms work to disrupt the behavior of these models. In past few years, adversarial machine learning has become an active area of research as the role of AI continues to grow in many of the applications we are using. There's a growing concern that vulnerabilities in machine learning systems can be exploited for malicious purposes. Researchers at CMU discovered that by donning special glasses, they could fool facial recognition algorithms to mistake them for celebrities. In this image, you can see how an AI algorithm can be fooled just by making some minor manipulations in the input data. Progress in the field of computer vision is one of the most important factors in the rise of the self-driving car. An autonomous vehicle has to be able to sense its environment and react appropriately. Researchers at Samsung, Universities of Washington, Michigan, and UC Berkeley showed that by making small tweaks to stop signs, they could make them interpret differently by different computer vision algorithms in self-driving cars. It's a technique that looks like street art to you or me, but it completely changes the meaning of a stop sign to the machine reading it. A hacker might use this adversarial attack to force a self-driving car to behave in a dangerous way and possibly cause an accident. Now that we have given a fair idea of what we are going to talk about, let us introduce the paper that we are going to present. This was a landmark paper that brought in tremendous attention of the AI community to the area of adversarial attacks. It showed us as to how an attack can be so precise that it can fool even the most sophisticated deep learning algorithms. So this paved the way for several other research works on how to defend AI models from such attacks so that they can be used in critical areas without the fear of being attacked intentionally or otherwise.